Have you ever just looked up at the sky and wondered if there's a hidden set of rules to all of this? I mean, what if the laws of physics aren't just random, but are actually part of some deep mathematical code? Well, today, we're going on a hunt for that very code. We're going to follow a trail of these seemingly magical numbers that, honestly, feel like they just shouldn't exist.
Okay, let's just start with this beast of a number. This is known as the Ramanujan constant. Now, at first glance, yeah, it looks like a total mess. But look closer. I mean, really look. It is so incredibly close to being a perfect whole number. That string of nines just goes on and on. So what's the deal? Is this just some bizarre freak accident of arithmetic?
And that is the central mystery we are going to unpack today. Think of us as detectives, piecing together clues from the history of math, from the very frontiers of physics. Our mission? To figure out if this baffling number is just a meaningless fluke, or if it's a clue, a necessary consequence of the way reality itself is built.
To get to the bottom of this, we first need to do a little time traveling. We're heading back to the 19th century, to a moment when the very foundations of mathematics, something everyone thought was solid as a rock, seemed to be cracking apart. It was a crisis that threatened to throw the entire world of numbers into absolute chaos.
You know, think about a simple number, like 6. You can make it by multiplying 2 times 3. That's it. There is no other combination of prime numbers that gets you to 6. It's like a unique Lego blueprint, right? This rule, it's called unique prime factorization, and it's basically the bedrock of order in our number system. It's something we all learn in school and just take for granted.
But here's the crazy part. That bedrock rule, the one that seems so solid, it can actually shatter. Mathematicians found out that if you just expand your definition of what a number is, say you start playing with things like the square root of -5, that beautiful simple rule breaks down completely. In that world, as you can see right here, the number 6 suddenly has 2 different prime recipes. And just like that, you've got chaos. I mean, how can you build anything predictable if your basic building blocks aren't even unique anymore?
So, faced with this crisis, did mathematicians just give up? Not a chance. Instead, they invented entirely new tools, brand new concepts designed to find and restore the hidden order that had been lost. They were basically searching for the guardians of mathematical symmetry.
And to fix this mess, they developed this brilliant concept called the class number. You can think of it like a failure meter. It tells you exactly how badly that rule of unique recipes is broken in any given number system. The higher the class number, the more chaotic things are. But a class number of 1? That's the holy grail. That means perfect, beautiful, predictable order is back.
And the solution they found was, well, it was both elegant and strangely specific. It turns out there are only 9 of these special number systems that have that perfect class number of 1. They're all built around these 9 integers, which we now call the Heegner numbers. They are the only guardians that can guarantee perfect mathematical order in their worlds. And hey, pay close attention to that last one on the list, 163.
And here it is, the big reveal. That mysterious, almost integer we started with, it's a direct consequence of 163 being the biggest, baddest Heegner number. The unique mathematical power of 163, its special ability to enforce perfect order, literally forces the value of e to the power of pi times the square root of 163 to be infinitesimally close to a whole number. So no, it's not a coincidence at all. It's the inevitable result of a deep, hidden symmetry in the universe of numbers.
But believe it or not, the rabbit hole goes even deeper. Because it turns out, 163 isn't the only number that seems to be hard-coded into the very fabric of reality. There are other special numbers out there that act like fundamental constants, not just for math, but for physics and geometry too.
This table, you could almost call it the coordinates of our reality. See, in the top row, there's our number, 163, from the world of number theory. But below it, you've got 137 from quantum physics, which controls how light and matter interact. And then there's 65,537 from geometry, which defines the absolute limit of what shapes you can draw with just a compass and a ruler. Each one of these numbers, from a completely different field, sets a fundamental boundary on our universe.
Let's just focus on 137 for a second, because this one is a huge deal. This number basically sets the strength of the electromagnetic force. If it were just a tiny bit different, say 136 or 138, it's game over. Electrons would either just fly away from atoms or they'd spiral right into the nucleus. Stable matter, stars, planets, you, me, none of it could exist. Our entire universe literally hangs on the precise value of this one number.
So, we have these strange, powerful numbers. What do they all mean? Well, To get closer to an answer, we need to look at the work of a man who seemed to understand this mathematical music almost intuitively, and then see how his ideas are shaping the most advanced physics being done today.
And that brings us right back to Srinivasa Ramanujan. This man was a self-taught genius from India who, with almost no formal training, filled up notebooks with thousands of absolutely profound mathematical formulas. He had this uncanny, almost mystical intuition for the deep connections between numbers, long before anyone else could even prove them. It's like he didn't just calculate, he seemed to see the hidden patterns of the universe.
In the very last letter he ever wrote, literally from his deathbed, Ramanujan described a completely new type of function he called Mach theta functions. And they were weird. They behaved almost like other highly symmetric functions, but not quite. They had this kind of mathematical shadow that broke the pattern. For nearly 100 years, they were seen as this beautiful but ultimately useless mathematical curiosity.
But this just shows you how the most abstract ideas can suddenly become incredibly important. That useless curiosity from 1920? Well, get this. Today, physicists have realized that Ramanujan's Mach theta functions are the exact mathematical tool you need to calculate the entropy, the information content of black holes in string theory. In fact, some theories now propose these functions might be nothing less than the DNA of gravity.
And this is leading us to the absolute cutting edge of theoretical physics. Right now, researchers are developing these huge, overarching frameworks that try to tie all of these threads together. And in these theories, the universe isn't a product of random chance. No, they see it as the execution of a predefined mathematical algorithm, a source code, where numbers like 137 and 163 aren't coincidences. They are essential parameters, hard-coded from the very beginning.
Which leaves us with this final, truly staggering question. When we see something like the Ramanujan constant being almost an integer, not by some random chance, but because of a deep structural requirement of mathematics, what are we even looking at? Is it just a quirky side effect of the rules, kind of like some high-level trolling by the cosmos? Or is this elegant, intricate, and deeply interconnected mathematical structure a sign of something more? A source code that we are only just now beginning to read?